Welcome back to another Forge College Explainer. Today, we're diving into the foundations of deployment strategies, which is a crucial piece of our broader track on deploying on Solana. If you remember our last lesson on troubleshooting network configuration issues, you know exactly how fast things can go south. So today, we're stepping into the shoes of senior engineers to sketch out the foundational blueprints for safe network deployments. Because let's be real, absolutely nobody wants to be the person who takes down the entire network on a Friday afternoon, right? So that brings us to the million-dollar question. How do we deploy safely without breaking, well, literally everything? Remember the sheer panic of a broken network config from our troubleshooting lesson? The only thing that saved the day there was having a lightning-fast revert path. Today, we're going to take that exact safe change pattern and scale it way up so we can manage full live code rollouts like pros. Here's our blueprint for today. We'll look at the deployment dilemma, explore 3 core rollout strategies, walk through a blue-green swap, tackle capacity planning, lay out a killer 6-step workflow, and then wrap the whole thing up. Let's jump right in. Part 1. The deployment dilemma. Let's look at what actually happens when our isolated config fixes meet the harsh reality of live user traffic. You see, every single deployment forces us into a corner where we have to balance competing priorities. We're constantly weighing how fast we can flip traffic against the overall safety of the system. We have to balance our need for deep, precise telemetry against the massive headache of actually setting it all up. And of course, we're weighing our resource costs against the user's lag. Honestly, it's kind of like trying to safely upgrade a car's engine while it's zooming down the highway at 80 miles an hour. It is a tricky balancing act. Section 2, 3 rollout strategies. Think of this as the engineer's toolkit. Let's crack it open and define the core mechanisms you're going to use to orchestrate these upgrades safely. Tool number 1 is the phased rollout. This strategy is literally like dipping your toe in the water before jumping in. You're releasing changes gradually to specific regions or maybe certain user groups using selective routing or feature flags. It's like expanding concentric ripples in a pot. By doing it this way, you tightly limit the blast radius if something happens to go wrong. Next up, we have the blue-green deployment. In this setup, we keep an active, let's call it blue, version running, while a standby green version runs at the exact same time right next to it. Once we verify the new green version is good to go, we use an atomic routing switch to send traffic over to it. It's literally like flipping a light switch in your house. It gives us an instant cutover and, more importantly, an equally fast rollback if we need it. Finally, the canary release. This one funnels just a tiny percentage of your live traffic to the new code. It acts as an automated early warning system, kind of like the old canary in a coal mine. By setting up really tight metric gates, you get to validate real-world conditions before the vast majority of your users even realize an update took place. Now, if we compare these 3 strategies side by side, the ultimate goal is matching the right mechanism to your specific scenario. Notice how blue-green gives you lightning-fast rollback speeds for high-risk changes. On the flip side, Canary is absolutely perfect for testing those performance-sensitive updates out in the real world without risking everyone's experience. You just gotta pick the right tool for the job. Okay, moving to section 3, the blue-green walkthrough. Let's take what we just learned and see how it builds into an actual orchestration sequence from code to action. So instead of boring you by reading raw bash scripts, let's visualize the logical flow here. Step 1, we deploy the new binary to our standby green target. Step 2, we run deterministic smoke tests to verify it's actually functional. Step 3, we route a portion of traffic, say 50%, so we can monitor the live telemetry. Step 4, we execute a full 100% cutover. And step 5, and guys, this is absolutely crucial, you have to save that old program ID. That is your instant rollback path if things suddenly go sideways. Do not skip that step. Let's jump to section 4, planning your capacity, the math behind the magic. Because now that we know how to route the traffic, we seriously have to talk about capacity so our new deployment doesn't just instantly crash under pressure. Okay, so here is the harsh reality of the cold start problem. Starting all your replicas at the exact same time without warming them up first is, well, it's quite literally like asking 100 people to sprint a full marathon the exact second they roll out of bed. They're going to stumble, they're going to fall, and it is absolutely guaranteed to cause a massive latency spike in your system. To prevent that total disaster, we use a neat structural engineering formula for capacity. It goes like this. Capacity equals your baseline requests per second times your anticipated spike factor, multiplied by 1 plus your desired headroom. Using this formula ensures you mathematically size your scaling before you ever hit that cutover switch. Let's actually put that into practice with some real numbers. Say we have a baseline of 500 requests per second, we're expecting a 1.5 spike factor during the cutover, and we want a 30% buffer just to be super safe. We plug that in, and boom, we must provision for 975 RPS. Doing this math up front is exactly how you avoid brutally hitting those RPC rate limits, which, by the way, is essentially the network just hanging up the phone on you because you're talking too fast. Section 5, the 6-step workflow. Let's take all of this and synthesize it into your master deployment blueprint. If you're studying in any Forge College program, you know we absolutely love a highly structured, repeatable process. This 6-step checklist right here is your ultimate operational blueprint. First, it demands that you define your success criteria, things like error rates and your P99 latency, which is basically the experience of your slowest 1% of users. Second, select your rollout strategy. Third, run your capacity math. Fourth, pre-warm those replicas to dodge the cold starts. Fifth, execute the rollout using automated metric gates. And finally, step 6, validate the system stability before you go cleaning up your redundant capacity. And that brings us to section 6, the wrap-up. We've sketched out the complete set of blueprints today, so let's do a quick final inspection of the core concepts. Here is the main takeaway from this explainer, broken down into a 3-part mandate. Number 1, always map your rollout strategy directly to your risk profile. Number 2, never ever deploy without precise telemetry and a fast rollback path. And number 3, remember that capacity and warm-up matter just as much as your code. A nasty cold start can absolutely ruin a functionally perfect Solana program. So as you gear up for our next lesson, where we'll be analyzing performance-driven deployment choices, I want you to ask yourself, what is your baseline latency for your next rollout right now? Do you know it? To master these exact metrics and continue your Web3 engineering journey with us, please make sure to visit forge.college. Thanks so much for joining me today, and I'll see you in the next explainer.